Well, welcome human biology class. This is the first lecture after the exam. At least I'm recording it at that time. And the final three sections in this class would include the respiratory system, which we're beginning today, the musculoskeletal system, muscles and bones, and then the nervous system. Those are the three that will be on the final. All right. So my plan is, since the coronavirus is so dominating our lives, and of course is a virus that largely affects, not only, but largely affects the respiratory system, my plan is to talk about the structure and function of the respiratory system, the parts that make it up and how they work. We'll do that first, and then at the end, along with some other ailments, we'll talk about the coronavirus's specific effects on the respiratory system. Okay, so to start things off, though, I'm going to take a little bit different tack and ask you if you've ever looked at maps in your Bible. When I was little, maybe sermon was a little over my head sometimes, and so I take out my Bible and I look at the colored maps in the back of the Bible. And always the Dead Sea was a prominent feature. But I never really thought that that would be a place I'd like to go see. I always thought of it as hot and barren and desolate and, Sodom and Gomorrah-ish, since they're right there. And I thought, that's not a place I want to go visit. So my question to you, I guess maybe you do, maybe you've been there, I don't know. But there's an interesting thing there. When I thought of it being barren and desolate, though, and if some of you have that same impression, if you actually go there, you'll see that, in fact, it's not that. There are a number of resorts, like the one that you see here. Okay, here's another look at some resorts in the Dead Sea area. Might be on the Jordanian side, might be on the Israeli side. Wow, these are some pretty palatial establishments. And you might ask, why in the world are people willing to pay what they must have to pay to go to the Dead Sea? Well, it's got its own unique beauty, but at least one of the reasons has something to do with the respiratory system. If you look at the Dead Sea right here, I think this is the Jordanian side, and you're looking across the Israeli side. These would be the Judean foothills over here, if I'm assuming correctly. And beyond the Judean foothills then would be the Mediterranean Ocean. Part of the reason this area is attractive to some people, and it is people with breathing disorders, is because the surface of the Dead Sea and its shores are the lowest point on Earth's surface. When you are on the shore of the Dead Sea, right next to the water, you are almost 1,400 feet below sea level. Death Valley is like around 300 feet below sea level. This is 1,400 feet below sea level, and the Dead Sea is like 300 feet deep, or no, it might be more than that. Maybe it's 300 meters. It's deep anyway. So anyway, here the Judean foothills, the Mediterranean Sea is 1,400 feet above you to the west. Well, you might say, okay, make the connection to the respiratory system. Here's the deal. If you are having difficulty in breathing, maybe you have asthma, chronic bronchitis, COPD, chronic obstructive pulmonary disorder or disease, that means you can't get air into your lungs well. When you're standing on the shores of the Dead Sea here, there's this huge layer of atmosphere above you, more so than anywhere else on Earth, pushing down on you, so that when you go to breathe in, there's more air pushing, more atmosphere pushing that air into your lungs here than anywhere else on Earth. Bottom line is, it's easier to breathe if you have trouble breathing on the shores of the Dead Sea than anywhere else on Earth. And that is why some people come to this part of the world. So here's the respiratory system. And there are lots of structures along the way we'll talk a bit about. We're going to start with the nose. Work our way down the airway, the trachea, the bronchi, and into the lungs. And of course the diaphragm is also going to be involved with this. And so to begin this, then let's start with a consideration of the upper respiratory tract, the nose, right here. Inside the nose then, the nose is kind of unique. It's one of those structures along with your ears that grows your whole life. The reason it does so is because the nose and the ears are predominantly made of cartilage, which actually begin to divide more rapidly as we age. If you've ever noticed your uncles or your great uncles or your grandparents, man, the ears can get big and the nose can get big. It's kind of distinct as we age. And it seems to happen more so in men than in women, although I have not seen a study to verify that. So ladies, when you get married, just look at that person you say I do to and picture them with a great big nose and great big ears when they're really, really old. That's what's going to happen. Maybe. Anyway, the nose. If you go inside the nose, you can see these layers, these little, look like decks or protrusions out of it. And one of the reasons they're there is to pre-warm the air here before it travels down the airway and into your lungs. And that's why on a cold winter day, if you are able to breathe through your nose, you'll keep your body core warmer than if you breathe through your mouth. Simply gulping air in through your mouth sends it directly to your body core, not pre-warmed, and you would get colder quicker. If you are able to breathe through your nose, it will get pre-warmed and then go down into your core and keep you warmer longer. The nose is a very vascular place. It means lots of blood vessels, lots of nerve endings there. You know that if you're out on a cold winter day and a twig snaps you on the end of the nose, oh man, my eyes almost water just thinking about it now. Also, those of you that have, I'm guessing most everybody here has had a nosebleed, or if you've been whacked on the nose, you know how easily it bleeds. It is a very vascular area. Because of that need to pre-warm the air before it goes into the lungs. The way it does that is through the blood supply. The blood system is doing the pre-warming. Okay? I want to look at another picture that highlights one of the uniquenesses, if you will, of the nose, and that is olfaction, the olfactory system. Olfaction is your sense of smell. And so here's the brain. This would be the cerebral cortex right here. Right at the base of it is what we call the olfactory bulb, and radiating out of that are these nerves that sense what you're smelling. You all know that if your nose is plugged, you have difficulty with taste, and so you know that this is tied in with taste. It has other uniquenesses to it as well. Olfaction is the only sense that goes directly to long-term memory. It is not processed by any other part of the brain. No other part of the brain is deciding to discard that particular smell or to associate it with some other event or something like that. No, olfaction goes directly to long-term memory. That's why when you're someplace and you catch an aroma, it can transport you immediately to a location or to a time, to a memory that you've had in the past that you remember that smell from. And olfaction is able to do that more so than any other sense that you have. And that is because of its structure, because it goes directly to long-term memory and is not processed by any other part of the brain. When we do, I'm going to do a sheep brain dissection, I will show you this olfactory bulb on the sheep brain, and just remember what we were talking about here. Okay, so the airway is tied in with the sense of taste. We know that. There is also this hole right here, or if I go back to the picture from your textbook, here, this hole right here. This is the opening of the eustachian tube, or the auditory tube, that goes up to the back of your eardrum. I think we talked about this before. If you go down a steep hill and you chew some gum or you wiggle your jaw, you'll hear that, you'll pop your ears. Well, you're popping that tube open right there so that the pressure equalizes on the back side of the eardrum and in your oral and nasal cavities. If not, you will feel pressure on your eardrum, and that's what popping it does. So your ears are tied in with your respiratory tract. So are your eyes. Here is a picture of the eye, and there are tears produced all the time with the eyes if you're crying, more so. And what doesn't run down your face actually drains into your nose. This light blue tubes here, one at the top of the eye, one at the bottom of the eye, drain tears directly into the nose. That's why your nose runs when you cry. Okay, so that particular structure is also tied in with the respiratory tract. And then you may have seen it here before. Another issue, another item, structure that's associated or actually an integral part of the respiratory tract is your sinuses. before I put that picture up there again, I shouldn't have done that. If I were standing in front of the whole class, which I wish I were, and I asked you, when you have you have a sinus cold or a sinus headache, and you feel that pressure from having that particular infection, where does it hurt? And I'm guessing some of you would say right in your cheekbones, or some would say right in my nose. Some might say in the forehead or behind my eyes. And would potentially be a bit of variability there. Well, the reason for that is because you don't just have one sinus, you have multiple sinuses. Here's a maxillary sinus. That's in the bone of your upper jawbone, maxilla. There are holes there. Right at the bridge of your nose, you have the ethmoid sinuses. In your frontal bone of your skull, you have the frontal sinuses. And then back here, deeper, there are the sphenoid sinuses. So all these are holes in the bones of your head, and are there for a purpose. Somebody might ask you kind of vindictively, well, you got holes in your head? And yeah, I do. And boy, I'm thankful for them. They let my spinal cord out. They let blood go in and out of my brain. They let nerves go in and out of my brain. And then I also have these sinuses. So holes in our head are a good thing. Well, these sinuses have some particular functions. One of them is to reduce the weight of the skull bone. And that's a pretty substantial bone. So it's good to be able to reduce the weight without reducing the strength of it. Sinuses are also there to produce mucus. That's what goes into our respiratory tract. That helps gather impurities from the air we breathe in, along with the hairs in our nose. They help filter the air that goes into our airway. And they also give tone to voice. Now, you can get a change in voice because of inflammation or infection down here in the throat, too, in the larynx. But sometimes you can get it because of inflammations here in the sinuses, and we know that it can change the tone of our voice, and so the sinuses definitely affect our voices. Okay, so we've gone through the nose, we've gone through the nasopharynx. The next structure right here is the larynx. So we've already talked about the epiglottis, the flap of tissue that keeps food that you swallowed going down the esophagus here and not going down the, quote, wrong tube into your lungs that we have here. We've already talked about the fact that if you do get some food going down your wrong tube, down your trachea into your lungs, it doesn't get into your lungs. In fact, some of you even notice that after a little bit of time, it actually reappears back in your mouth. And we'll talk about how that happens. But right now, let's talk about the larynx just a bit, your voice box. And that's located right here. And it's got, of course, some very distinct features. Of course, one is the main one is to give you speech. It contains the vocal cords. And your textbook has a nice artist's impression of vocal cords right alongside a real image of vocal cords. Vocal cords aren't like harp strings where you've got multiple chords that can create different pitches or sounds. You've got two vocal cords, one here and one here. And moving them back and forth in association with one another, you might bring them together, you might separate them farther apart. That can create the different pitches that we hear in a person's voice. Males tend to have longer vocal cords, which gives a deeper pitch. That's also why we have trouble with puberty, with controlling our vocal cords, because they can lengthen quickly at that time, but males have not established good muscular control over them, and so the voice can crack. Women tend to not have that because your vocal cords tend to be a little shorter and they're more well controlled. Yeah, maybe I'll just leave that statement right there. Your vocal cords are more well controlled. Boy, in life, I wish my vocal cords were more well controlled a number of times. Anyway, so there is an insertion here on Moodle that I would like you to take just a moment to look at. It's called vocal cord surgery, and you can see how a surgeon through a microscope would operate on that part of the body. Now, in this video clip, it's only 2 minutes long, they're going to remove polyps, cysts, and nodules. Okay, polyps in the vocal cords, you think of polyps with the digestive tract, particularly large intestine, that's a bad deal, they're precancerous. That's not the case in vocal cords. You'll have polyps there, they're not ever precancerous. But the polyp, I think that's the first one that you'll be operating on. They tend to have a lot of blood supplied to them, and you'll see it, bleeding some as he cuts it off. They tend to be larger and stick out more than nodules. They can be caused by acid reflux, smoking. Now, I'm not just saying cigarette smoking. In this day and age, with this country's fascination with marijuana smoking, it's the same deal. You're going to get vocal cord polyps just as well from smoking pot as you would from smoking tobacco. But with two of the three issues that he's addressing, singing, or they call it vocal cord abuse. I hope that's not an indictment of the person's ability to sing. It's just how much they're singing. I always think of like, it was AC/DC, not that you should know what they sound like, but that lead singer, or the several lead singers they've had through time, that what that person is doing to his vocal cords, it's got to be pretty extreme. So those are ways you can develop a polyp. The surgeon will also remove a cyst. Cyst is a little different from a polyp. It tends to grow in a pouch or a sac. And it's not usually from overuse, but he's going to also remove a nodule. That's the last one. And you'll notice there's really not much blood associated with this one. That makes it a little different than a polyp. And it tends to be in the middle of the cords where the two cords meet. And again, it's very common for a singer, and you probably know of some singer that's had to take some time off or had vocal cord surgery because they've used their vocal cords too much. And yeah. And so that's what that's about. There's another clip there of a gentleman. He's actually trying to sell you a product, but an artificial larynx. And I'll show you an image here. This gentleman right here has had a laryngectomy. For some reason, if it was cancer or who knows what, he has had to have his larynx removed. And so this device is what people always used to hold up to that, and it sounded like you're holding an electric shaver up there, and they would talk at you in this monotone voice. And so the other clip that I'm having you look at is a guy that has a device that is able to modulate or give you different levels and tones as one is talking. But this technology has gone even well beyond these devices. I know some people with artificial larynxes now that you would have a very difficult time even knowing that they had an artificial larynx, other than the fact that they keep that portion of their throat covered at all times, whether it's with a scarf or some particular type of clothing. This technology is really expanded impressively. Okay, so that's a little bit on the larynx and some additional items that I would like you to look at this point in the lecture. So you can pause this, go to those links, look at that, and then come back if you would. And we're just going to finish up with an introduction to the trachea. Okay, right here. So we've gone down the airway here and past the larynx. We've gone through the nose, through the nasopharynx, past the larynx to the trachea. And the trachea is really just stacked rings of cartilage. They're C-shaped, so they kind of be open at the back where the esophagus would rub against it, and you can actually put your hand on your throat and you can feel that larynx. We did this before, not the larynx, well, you can feel the larynx too. You can actually feel it vibrate as you talk. But below the larynx then, you'll actually feel the trachea. It's a little bit uncomfortable to press too hard on it, but you can press the size of it, particularly the size of your larynx, and you can feel that's a pretty rigid air tube there. You don't want it to collapse. You don't want the sides of this to stick together like your eustachian or auditory tube does. And so there are cartilages there to give it some rigid structure, and that's what makes up the trachea. C-shaped cartilage segments. Now they're lined with cilia. So in your textbook here, there's a really nice picture of that lining. It's an artist's rendition of the lining of the trachea. Okay, so this would be where the air is right here. And we talked about swallowing something down the wrong tube, or maybe there's just something you breathed in, some particle, it's going to find itself in the mucus at some point along the side of the airway. And these little cilia here just act just like a broom, and they sweep it up against gravity, up and out of the airway. And that's why if you swallowed something down the wrong tube, you may have discovered it back in your oral cavity in your mouth a little bit later, because the trachea has these cilia that are on the tops of these epithelial cells. Remember, lining, the epithelial cells cover and line. So this is the trachea, so they would sweep it right up and out. And so you have a really effective system of keeping debris out of your lungs. Now, I'm guessing some of you might live with a person that smokes. Maybe mom, maybe dad, maybe you're married and live with somebody that smokes. I don't know. You got to talk them out of it, people, because that is something that will kill them. Well, one of the things, if you can think of somebody that is a smoker, one of the first things they do in the morning when they get up, if you were in class right now, I would ask you, and I have not failed to have a year when almost everybody figured out what I'm after. What's the first thing that a smoker does in the morning? They cough. They hack and they cough. And the reason is because cigarette smoke basically anesthetizes or paralyzes the cilia as a person is smoking. And so I think marijuana smoke does the same. I think it might even do it worse. So these cilia are paralyzed. So when a particle gets caught in the mucus, it doesn't get swept up out of the airway. It just keeps going down and down and down and settles. And so all day long the person is smoking, and that debris is settling down in the bottom of their lungs. Then they go to bed, and they're not smoking at night, obviously. So they wake up in the morning, and there's all this debris down at the bottom of their airway. But they've been laying prone. Well, when they stand up, the first thing that happens is those cilia want that stuff out of there. And so they go into a coughing spell. And what their body is trying to do is expel all that debris that accumulated down here in the bottom of their airway through the day and get it up and out of there and spit it out into the toilet or whatever other disgusting thing that they do with it, I don't know. That's what's going on. And that's how your airway functions. So it's just really, you are really fantastically made, fearfully and wonderfully made. Look at the epithelial cells lining and covering the inside of your trachea. Again, this would be the lining of, this would be inside of your trachea. There would be another picture like this on the other side over here for the other wall of the trachea, and it's actually a tube, so it'd be completely surrounding that air tract, and filtering and moving debris up and out of the airway. The last image I'm going to have for you in this lecture, oops, wrong one. If I go back to here, you can see right here, this is the trachea, and as it branches right here, it branches into two primary bronchi. And what I wish this picture would show was that would be that there would be less cartilage, the white stuff here, and more muscle, the red stuff here. As the airway descends into the lungs, the amount of cartilage decreases and the amount of muscle increases. And that muscle gives the body the ability to constrict those air tubes and make them smaller. And sometimes we don't want this to happen. We can get a histamine response. Histamine makes things swell up, if you remember from the lymphatic system and immunity. And you'll get a histamine dump in there. It might be from an allergic response. It might be from an irritation. Who knows what. And so that tissue can swell up because of that. The muscles can also change the diameter of the tubes. At any rate, this is the trachea. These are the bronchi. As the bronchi enter the lungs, they're made up of cartilage and smooth muscle. Smooth muscle means we don't have to think about it to make it contract. It does it automatically because of directions from the brain or responses to stimuli elsewhere. So anyway, trachea, mostly cartilage. Down here is the bronchi, cartilage and smooth muscle. And the farther you go down in the lungs, the less cartilage there is and the more smooth muscle there is. And so we're down in the lungs at that point, I'm going to stop lecture right now, and we'll pick it up with a consideration of the lungs, how they're made, and how they work next time.